Now, typecasting, which means this. Typecasting is not compulsory. If you don't use this, it's totally fine. If you're a person who gets confused with this, don't use this at all. It doesn't matter. Just focus on the right hand side of malloc. Um, it's not compulsory. Okay. Now, if you notice, my loop is going from 0 till len, and len is 5. So it's going from 0, 1, 2, 3, 4, 5. Do you think my malloc memory that I made using malloc has 5 locations in it? Can it store, sorry, 1, 2, 3, 4, 5, 6? Can it store 6 variables in it? The memory that I made with malloc. Cool. Nice. So keep in mind that sometimes they do give you these tricky questions, tricky in the sense that you have to have detailed knowledge about these things. So there's one error here. Let's see over here. So there's only one dereference. I like to call this as a dereference operator too, because it acts in the same way pointer acts like this, these two things. I've said this a lot. I keep saying it so that you all remember this, but yeah. And then there's ARR2, which is equal to ARR1. So I'm going to make ARR2. Let's say the address is B. And it's telling that its value is equal to ARR1, which is X. So I'm going to make it point to that X. So far, I think it's fine. I don't see any issues. Apart from that, when I go to this line 10, it says to free ARR1. Whenever you say free ARR1, that means that you're supposed to free to whatever it's pointing to. So you're supposed to free this. Now this doesn't exist anymore. This gets deleted. And now it's pointing to somewhere in the system where I don't know. Maybe null, maybe not null. Now going to this line, I am trying to use ARR2 at this particular location. I'm telling it to go to this index, dereference, and get the value. Do you think this will work?
Yes.
Cool. Why do you think this will work?
Because AR2 is now pointing to whatever AR1 had.
Cool. So if you remember, we had this memory allocation, and when we said ARR1 free it, what it did is it just deleted that memory allocation. Right now, both of these were pointing at the same memory allocation because that is what we did in line 9. And now both of them are not pointing anywhere. It's like somewhere in the system. And now when I say ARR at 0 index, there will be segmentation fault because it's pointing to some place where I don't know, and even it may point to anything corrupted. So the compiler will not try to access that, and it will tell you that there's a seg fault for this case. Because when both of were pointing to the same thing, I deleted their access to that memory allocation. So now it's pointing to nowhere. I mean, it's pointing somewhere, but then it might not be good enough. So it just doesn't let it get that value because there might be some issues with the value where it's pointing to. Okay, coming back to this one. So it's val equal to 100. Let me see what val is. Okay, val is also a pointer. Let's say its address is C, and I'm telling it to point to 100. So do you think I can store integers just like that in pointers? Cool. Okay. So no. For pointers, just storing integers like that is not allowed. You should not use pointers to store pointers like that. Because right now, my val, what is happening is, sorry, my diagram was also wrong. My val, it's not initialized. For example, let's say if I had int a, and if I was just printing int a, do you remember when you just printed int a without giving it any value, it just printed some random value? So in that way, if you just never made val equal to address of something, because it's a pointer, pointers can take only addresses, and double pointers can take the addresses of pointers. Nice. Um, so right now it's you never initialized, you never gave val a value. And now you're trying to, oh, there's so much going on this page. We'll try to erase some of it. And now what you're trying to do is you're trying to dereference val and give it some value at that address. You don't know where it's pointing to, first of all. You have no idea where it's pointing to. And you're telling that store 100 in that address. That's not a valid thing. Again, it's the same thing that's happening. So that is not a valid statement. Seg fault again. And then the other line, this one, matrix equal to int malloc len into size of int. Do you see any error in this? Nice. Over here, if you see that my matrix was a double pointer, where is it? Yeah. My matrix was a double pointer. Double pointers store addresses of pointers. So whenever you're doing malloc, that means that you're creating memory, a space, and you're telling it to create that much memory, which is len, which is like 5. And then everything inside of it should be an int. No, that is not possible. It cannot it cannot point to a memory which is filled with integers. It should point to a memory which is filled with pointers or addresses. Like everything here should be an address, not an integer. And then these addresses will be pointing to integers. That is how it works. So keep in mind that if you see double pointer here, you just put one pointer here, one less of that, always, whenever you're doing malloc. 2, 1. And if there is 1 here, 0 over there. And then if there's nothing over there, you don't even have to use malloc. You cannot use malloc. Malloc is just for memory, not for integers. Okay. Now in this one, it says int I equal to 0, I is less than len, which was fine. If you saw earlier, we did equal to len, which caused something like array out of bounds error. Over here, it is fine. And then in this case, I did matrix dereference once. So let me draw the diagram for this one. Matrix is a double pointer, assuming that everything was fine in line 9, sorry, not line 9, 15. And everything here is a pointer or address. And then these are maybe pointing to an array of integers or just one integer. Okay. So now matrix is going over here and it's trying to dereference whatever the value is at I. You can also write matrix plus I and then just dereference it. Both of them mean the same thing. So let's say I is equal to 0. So it's going to this particular address and then getting the value from it, which is this address, this pointer. And then it is telling you to put this memory allocation over there. malloc, sorry, I don't know why I'm writing that, malloc len into size of int. Do you think this will work? How many of you think that this will work? You can just raise your hands. Okay, cool. Nice. Okay. Um, let's try to erase everything that I did so far. It's all about understanding addresses. So I'm just trying to make sure that you all understand that. So A is the address of matrix, X is the address of the first index, the second index, the third index, the fourth index, so on. And let's say this, the address is stored inside of these indexes, the values inside our addresses. Let's say it's um 3b, 3c, 3d, 3e, 3f. And then these addresses are pointing to the address 3b. Let's say the value is 5, is pointing to an address 3c. Let's say the value is 6, 7, 3d. Okay, so now you're telling to dereference. That means when you dereference matrix once at I, when I is equal to 0, the value for dereferencing is 3b inside. And you're telling 3b is equal to malloc. So you're telling this pointer to point to a memory address or create an array of that address. That's all you're doing. Cool. So I think there were like 5 errors in this one. And I will be posting an answer sheet so you all can also take a look at that. Okay, coming back to this one, is there anyone who wants to tell me the first problem in this code?
Sorry, actually, I have one question.
Mm-hmm.
Back on the previous, on line 16, you
Yes.
wrote I is less than or equal to length, but then well, before you erased it, was that I don't know if I missed that section for line 16 on the for loop. You
Yes.
wrote I is less than or equal to length. Wouldn't
Mhm.
it be I should be less than length? Because then if it's equal to when it reaches 5, it's going to try and access something that's not in the array or
Nice.
not.
Um, when you were not here in this session, we were talking about this being an error in this.
Mhm.
So this question was finding the errors that you can see in the code. So yes, you're right. This will give you an error.
Oh, okay, okay. Thank you, thank you.
Mhm. Okay, coming to this question. Nice. Okay, I already got an answer. Line 5 is the first problem. Cool. Okay. So I have str1, not a pointer. I have str2, pointer. And is my str2 initialized? Did I give it any value? Cool. So if I have not given it any value, can I say str2 is equal to str1? Nice. Because remember, str2, if it was maybe an array, cool, yes. str2 is right now not pointing to any valid memory address, so I cannot just tell it to get the value and store it at that address. Cool. There's no malloc. You have not made it point to a valid address. You cannot just do that. Keep in mind. str1 has a valid address, but str2 doesn't have a valid address. And even if I change their positions like str1, str2, that still would have not worked. Okay. This malloc looks fine to me. This one also looks fine to me. Keep in mind, if it's just one pointer over here, there's 0 pointer over here. Okay. Now, coming back to line 8, just make sure that it's starting from the right point, ending at the right point. And then P1 dereference I, which can also be written as P1 plus I dereference, same thing, equal to random 100. If you don't know what rand is, don't worry about that. Is just telling it to create a random value from 0 to 99. So don't worry about that. And then I see P2 equal to P1, which just says that whatever address is stored at P1 is equal to whatever P2 value becomes equal to P1's value. So let's say if P1 was pointing to X address, P2 will get that address. That's what it says. Apart from that, I'm trying to dereference P3 and make it equal to 50. Do you think this will work? Nice. Again, you have to make P3 equal to some address. After that, you can make it. But before that, do not dereference. Don't do the dereference before that. Make it point to an address, then do dereferencing. Without making it point to a valid address, don't do any dereferencing. Okay. P4, is it a double pointer? Okay, yeah, it's a double pointer. I'm doing malloc, size of, I see one pointer, that's fine. And then for int I less than n, that looks fine too. Over here, I do P4 dereference I. So when I do P4 dereference I at that particular index I, or at that particular location, what is stored? Is address stored or is an integer stored? Nice. Address is stored. So do you think I can put -5 at that location or at that index? Cool. It's an integer. You cannot store an integer at that location. You have to store an address. It's a double pointer. So you have to store an address, and then that address is going to point to somewhere else that right now we don't know where. Cool. Okay. So line 15, free P1. So P1, did I ever free it? Nope. I can free it right now. And then free P2. Just make sure that P2, oh yeah, P2 is equal to P1. So P2 was pointing to the same address where P1 was pointing to. And in that way, when we feed this address, both of them are pointing to somewhere we don't know. But in that way, whenever you do free P2, that means that it's a double free. Because we have already freed P1, both of them were pointing to the same address, so double free, that is another issue. So make sure that whenever you see something like this, just check if it's double free or not. And then free P4, I don't see any issue with that. It just frees this address that you made using malloc. Okay. Are there any questions before I move forward with both of these questions? Are there any questions that you have? So nice. You can do either of them. You should have either done P2 that would have been fine, but don't use P1 or just free P2 or just free P1. Just write one of them, not both of them. Okay, 1, 2, 3. I think 4, I think, or 5. Wait, 2, yeah, 5. Wait, I think 4. Yes. Going back. Nice. Okay. Someone did point out a good point. Do we have to make a for loop to free the pointers inside for P4 as well? Good question. If you see over here for P4, I just made enough location for malloc for this one, just for this case. So if you see one malloc, just do one free. If there was another one, let's say if there was something else where I did P4, let me erase all of this because it will get confusing. So the question is that if you did P4 free, shouldn't you free the things before that are inside of it? That is a valid question. But over here, we don't do that because when we did P4, we just used one malloc. That means that we only need one more free. But let's say if you had a for loop where you made sure that you did P4 at I equal to malloc, size of so on and so on, then you would have first had to make a for loop and then free things. And then after that, you had to free P4. But we didn't do that here in this program. Over here, this was an error, if you see, so we didn't have to do that. And then someone said that didn't we already use malloc for P2? You did point out a good thing that I forgot to talk about. P1 is pointing to some place. P2 is pointing to the malloc address that you made, both of them. Then later on, what you did, you made P2 equal to P1. So P2 is right now pointing here, and it's not pointing here. So my bad. So it's now pointing to wherever P1 was pointing to. It was Y, but now it became X. This, you shouldn't do that. Before you do that, you had to free P2, and then you could have said P2 equal to P1. That would have been valid statement over here. And then over here, the reason why it's a double free is that both of them are pointing to the same memory location. So when you free X, that means both of them are pointing somewhere in the system that we don't know. So if you try to free P2, compiler will see that it's not a valid address that it's pointing to, so it will not let you free it. Because both of them were pointing to the same location, but now as you free just one location, everything is gone. Okay, cool. Is everyone fine with this? Nice. All right, moving on. So all these are the next ones are maybe coding questions. So for the coding questions, always keep in mind that you have to read everything line by line. You cannot be lazy with this, especially if you see that there's a big paragraph like this. Most of your time is going to go in reading, and then coding will be like 5 lines maybe. So be happy that there's so much going on in that question that you don't have to write any big code. It's always the other way around. And if there's not much information given in the question, then you have to write a lengthy code. That is what I can say from my experience. Okay. All right. So there's a structure, bank account, and it stores name, account number, balance, and this is the nickname for the structure that we made. If you notice over here, char name, it's an array, it's a string, it's not a pointer. So do you think you can use malloc over here for this name? Cool. Don't use malloc for that. If it was char name, use malloc before you give it any value. But if it's just an array, don't use malloc for that. The same way, don't use malloc for n, don't use malloc for double. Whenever you see pointer, use malloc, then give it any value, like dereference. But don't do it for this, because I've seen that students will do malloc for this, even though it's just an array. Cool. No star, no malloc. And suppose two people decide to merge their bank accounts into one joint account. So write a function, merge accounts, that takes two pointers. So we already have two people with these two bank accounts and returns a new dynamically allocated bank account struct. But we have to return a joint account. So there are some instructions that are given over here, which says that the new name for the bank account is both the holder's name plus this. The number is equal to the smaller one out of both of them, and the balance is equal to the sum of both of their balances. And then it says that make sure you allocate memory properly for the new bank account and its string fields. So when you say deep copy, it's just that you're copying the same thing as their name. Like everything is going to be exactly the same from it. That's what it means. Don't worry about deep or what deep copy is. The caller of the function will be responsible for freeing the returned struct. So you don't have to do any free. Don't do free until they say you to do free. So free, no. You just have to focus on making or allocating memory for this new bank account. You don't have to focus on free. So don't do free until they tell you to do free. All right. So before we begin, what's the first thing that you have to do over here, according to this question? This is a dynamic memory allocation, so cool. Make a new name. Awesome. Do we have a new bank account yet? Nice. Um, okay. I have to already use the. Okay. Yeah, that works. So we have to make a new bank account pointer as someone stated because we don't have any memory for the new bank account. So that's what I'm going to do. I'm going to use that same, where is that? Wait, not that. I've never tried typing on an iPad, so bank account pointer, and let's name it A3 or maybe new. We can name it new. So bank account is the data type or the structure name that we will be using. And what should we make it equal to? Malloc. What should be the size of? Do you know what should the size of be? Nice. bank account. Cool. So it's a pointer and it's pointing to this address, and that address has all these things inside of it. And then in the end, I can also draw a diagram to show you how it looks like. But for now, if I'm in typing mode, I'll be in the typing mode. Okay. And then what we have to do is we have to dereference everything that's inside of this address. So we have name, we have number, and then we have the balance according to the structure. So in this case, we have to see. Okay, before you do this, I don't know if your professors told you this or not, like if it's compulsory or not. I don't think it's compulsory, but it's always a good thing. Not here, but in coding, I would say. If new is equal, oh, no, equal to null, then you can just, oh, so I cannot use tab space. Wow. Just return null. If you want, you can do it. I don't think so. They will cut any points if you don't do it in the exam. But if you feel like doing it, you can do that. Deep copy just means that you're copying the exact same thing from it. Don't worry about that. I don't think so. For this exam, they will be asking you anything like deep copy, but it's just copying the exact same thing from it. That is what it means. Okay. Apart from that, what's the first thing that we have to do? We have to do name. So for that one, we will be doing printf wait, new, and as new is a pointer, so you have to use this arrow thing and then try to access its name. And then you can just do something like this. So for strings, the format specifier, where is that symbol? I'm struggling with this. And then I also have to put this and where is it? This one. And I'm going to explain you why we have to use this arrow, or if you don't remember how to use arrow, then the other things. But it's again, I'm in like this typing thing, so I just cannot shift to drawing it out. Name. Okay, so it wait, did the question tell it to make it equal to that, or did it just tell it to print? Cool. Okay. For now, we will be printing it because it didn't specify if we were supposed to make it equal to that, but we will also make it equal to that soon. And then apart from that, new account number. Is that what it said? Yeah, account number should be equal to wait. It said that the account number is equal to the smaller of the two accounts, so I cannot just write that. If A1's account number is less than A2's, oh, this is A2's. For the next question, I think so I'm not going to use that. I will not be using this typing. Then new account number is equal to A1's account number, else new account number is equal to A2's account number. And then it said for the balance, may have a balance equal to the sum of both the balances. So new, is there anyone who wants to tell me how to type this? Okay, let me talk about the printf later. I will come back to that. Let me just finish this. Because that is not you cannot save it using printf like that. This is it called balance? Yep, it's balance plus A2 balance. Okay, think this is it for coding. Okay, now I can take those questions. So for printf, this is not how you save it. You have to use strcpy. I thought that the question asked me to print their names, but over here it says deep copy, so I have to make sure that everything gets copied into it. Yeah. Thank you for noticing that. Yes, it's balance. We'll make sure that in the answer sheet it will be fine. Okay. I'm not going to use, I will not be using typing for those next questions. This was bad. Typing on iPad is bad. strcpy. And what you do is you do new name, comma, whatever new name you want to store into it. So you just do something like, no, wait, don't do this. Don't do this. This is not how you should do it. I have lost my mind. Where is it? Before you do that, what you have to do is you have to, for the string, don't make the same mistake as I was doing right now. New name, which is an array. What you do is you just make it equal to A1 name and I think I did something wrong with that question. How many of you know what strcat is? So for strcat, what you have to do is you just do new name and then A1 name. After that, again, you do strcat. My bad. You do strcpy so that it makes it equal to this. Because for strings, you cannot just directly do equal to that. You cannot use that equal to sign with strings. And then for strcpy, new name, For this case, to avoid this, you should use strcpy, and then for strcat, again, you have to do new name, comma, space, and space, and then strcat again, new name, comma, a2 name. Let me explain you how it works because I completely forgot. I was so confused with the typing that I forgot how to do this. It took me time to come back to my senses. Okay. So for this one, as you know that let's say if A1's name was equal to Anna and A2's name was equal to Bob. So what it does is new name is equal to Anna. That is what it does. First of all, whenever you do strcpy, what I do is wait, there's so many comments in this. I will come back to this. I should have not used the typing. Cool. Yes. Yes, you're on the right. I did understand you explain. This is getting out of hand. Wait, can you see the screen? No. Let me share the screen. Can you see the screen now? Yes. Okay. So whenever I see strings or any pointers with char type, I always use string functions like strcpy, strcat. So for strcpy, it did this where it said that new name is equal to Anna. Again, don't use equal to sign with strings. Always use strcpy. I just avoid using equal to signs with strings because they might cause me problems in the future. And then later on, what I did is new name is equal to Anna plus whatever this was in the second one. So strcat is like just adding extra element towards the end. So many students get confused that which one should be used first. Always keep in mind it's from left to right. So if you're using new name before, it's on the left hand side of the equal to sign, and the second parameter is on the right hand side of the equal to sign. And this new name is always on the left hand side, and then this is always on the right hand side. So that means that I'm adding this towards the end. And then later on, what I did is I added one more thing. I did new name equal to Anna plus this, which was already there. And then I just added one more name to that. Is everyone fine with this? And then I printed it later, like just how I printed this. No need to do all of this. You can just do new name, address. Sorry, not address. Just the string, comma, the new name. No need to do that. I just don't know what I was trying to do. Maybe like I was trying to do S in printf. Yeah, S in printf, but you all did not study that, so it's fine. Wouldn't it be Anna? It will be both of this. So in the end, it's just going to print this. Anna, Bob. That is what it's going to print in the end for the new name. Yes. For most of the students, as I said, that you all struggle with using this arrow or this dot arrow, keep in mind that whenever you see a pointer, if that struct is a pointer, then you use this to dereference or access the things inside of it. Let's say if I have this name, account number, balance, and then you have what is it? This bank account, which is a pointer, and it's pointing to their address, which is X. So it's also going to be X. Now, when you have to access all these members inside of the structure, you have to first dereference your pointer. So you dereference it using this pointer. Keep in mind, whenever I use this dereference operator in front of bank account, I just use that to show it to you. Yeah, the dashes were supposed to be space. My bad. The dashes that you saw before were spaces. When I use this pointer in front of bank account, I just do that to make sure you know that it's a pointer. But to be honest, I prefer not to use that because that pointer is only used when you're making a pointer, and the only other time when it's used is to dereference that pointer. So for dereferencing, what I do is I use the same pointer that I did, and as you can see, when I dereference it, it tries to go inside the structure and look at all the values that it has. So it has name, account number, and balance. So it has many different things inside of it. Now it doesn't know which one to dereference. There are many things inside of it. So you use this access operator and you say that I want to dereference name. So that is how you do it. But instead of doing this, you just simply use arrow. So instead of doing this, you just say arrow. If you want, you can use the first option or second option. Both of those options are fine. Just make sure you're using it right. So if you don't understand how to use the first option, just stick with the second one. Whenever you see that the struct is a pointer, use an arrow. If that struct is not a pointer, just use this access operator. All right. Are there any questions or did I make any mistakes? Oh, okay, cool. Yeah, I can do that. That shouldn't take more than a minute because this typing took lots of my time. So where is it? Where is that statement? Okay, here is the statement. Um, mm, and to visualize it, again, I have a pointer. The name of my pointer is new. And let's say the address of new is A. And I'm making malloc size of bank account. So there's a new memory space that's being made just for that with name, with what was the name? Was it account number? Yep. And balance. If a structure is a pointer, this is the struct name, the data type. I know that most of you don't even know what that structure is a data type. Keep in mind that structure is a data type. It's similar to int star new. It's just that bank account is the data type that you made. If there is an array of bank accounts, would you use? Yes, if there's an array of bank accounts, let me tell you how to do that. Let's focus on one thing at a time. First, let me draw this and then I'll come back to that question. So bank account star new. If you see this pointer in front of your data type or struct name, it's a struct pointer. And you have to always make sure that you're making space for it. Okay, and then let's say that its address is, again, X for this entire thing. And then you're telling that this pointer is pointing to this address because you did malloc for that. You said this new account, sorry, this new pointer is supposed to point to this memory address that you made. So it's pointing to X. And then again, it's the same thing. Dereferencing, to access any of these members, you have to dereference it. You use this. And then as soon as it goes, it's like you go inside the fridge and you have too many options to choose from inside the fridge. You have to tell it what option you want from the fridge because it has three items there. So you just tell it to which you just tell it which item you want to choose, like name, once it goes in that inside the fridge. So it's like saying that make pointer, tell pointer to go to that fridge. Dereference is opening the fridge, and then this is just selecting which item you want from the fridge. And then someone had a really good question about this array of struct pointers. This and these two things mean the same thing. So as they mean the same thing, if there was an array of pointers, you would use bank account. And then you would use this because it's a dereference operator, and you just tell it which index, let's say I dot name. It's a dereference operator. So instead of using that, you just use this. And then when it comes to arrays, don't use this arrow. Arrow doesn't help you with that. All right. Okay. Now to the next one. I am not going to text. This one again says deep copy. Deep copy just means that you're copying everything from it into this new thing that you made and not missing out on anything. So it says that this structure wait, I was just reading questions. Okay. The employee key struct stores information about staff members. Write a function that creates a new array containing only the employees who have a salary of at least 50,000. Count how many employees meet the criteria and update the PTR count. So what you're doing over here is that you're creating a function. And for this function, you have a pointer list. Int n, did it say what n is? Okay, I think n is the number of employees over here. And PTR count is just telling you how many employees have salary of above of at least. So greater than equal to 50,000. Okay. So for this one, count how many employees have that, and then dynamically allocate an array for the results. So for this question, I would say the question is not framed as detailed as you would get in an exam. So don't worry if this question is something that you don't understand. In your exam, it will be more in detail. It will tell you everything that you're supposed to do. This question is not properly phrased. So you have a structure for the employees with their name and salary, and then you see this list. So I would assume that this list pointer is pointing to this array of many employees where everything is like employee, 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 which is just struct. So everything is a struct over here. And all of them are just struct, not pointers, because this is a single pointer. So everything is a struct. And then n would be the length of this array, I would assume. Yeah. We have another integer, which is a pointer, and we have to store the number of employees that have salary of at least 50,000 in this pointer. Okay. So for now, for this question, as this is a pointer, I need to store the address of the number of employees that are stored over here. So for this one, I would just start with making the number of count. Let's begin with 0 because we don't know how many employees are going to have that much salary. There might be 0 employees who will have that much salary. And this is already a pointer pointing to this array that's given to us. So we will be using already created data. Int I equal to 0. I is less than n. N is the length of that array of employees. I plus plus. And then I'm just going to dereference every single time. Go to I dot, and I'm going to check their salary. I don't care about the name right now because it didn't tell me to check whose names begins with A. It just told me to check for salary. And I'm going to check if it's at least, which is greater than or equal to 50,000. If that's the case, then what I'm going to do is increase the count by 1. Is everyone fine with this so far? Cool. And now, after it's done, what it does is it goes through every single index and sees if their salary is greater than or not. If it's greater than, it will increase the count by 1, 2, 3, 4, 5, and so on. And then later on, after doing that, I have my pointer, which is already declared, so I don't use int over there. But what I'm going to do is I'm going to make it equal to PTR count. So did it say that count? How many employees meet the criteria and update PTR count? So it says that PTR count is already pointing to an address. So I'm just going to dereference that and say that its new value should be equal to count. Again, I know that this question is not a good question with a good phrasing. So don't worry about that. In the exam, it will be better. So meet the criteria and update PTR count. So PTR count is already pointing to somewhere, an address, and you're just telling that the new address will have this value inside of it. Okay. And then let's say if there were not any employees with that much salary, which is like the base case. So if PTR, no, wait, I can easily use count. No need to use PTR. Count is equal to 0. Then I'm just going to return 0 or not. Okay, this is another thing that you look at the type of the function. Right now the type is employee. So that means that you need to return a pointer or null. If it was int or double, return 0. So I'm just going to return null over here. Because as the count was 0, there is no need to add or create another structure with just 0 thing inside of it. So you just, yes. Cool. That's what we are trying to do. Yes, we are trying to create a new array. But even to create a new array before that, I have to make sure that there are employees in that old array. No, if you just do 0, it won't be fine. I don't know, it might work on few people's systems, but it won't work on everyone's system. So I just avoid using 0. If it says that it's of type string struct, I always use null. And if it's of type int double, I always use 0. So I don't use 0 for this one. So yes, we are supposed to create an array. But before we create an array, we have to make sure how big my new array should be. I don't know how big my new array should be. That is why what I'm doing is I'm looking at my old array that I have, and I'm seeing how many people's salary is greater than or equal to 50,000. And then what I'm doing is I'm taking the count from there and creating my new array, because I don't know how big my new array should be. So now that I know that, let's say if count is 5, that means that I'll do malloc for 5 structs. I'm not writing it properly. I'm just giving you an example. If I had known, if the question had given me that there are 5 employees, I didn't have to do this step that I did just now. Okay. So now I can create a new pointer array to store all these employees with this much salary. So now it's employee T. So what I do is I write employee T. It's a pointer array because I'm storing an address, so I need a pointer. Let's say new equal to malloc size of, everything inside of this is going to be an employee T. Everything inside of this array is a structure. And how many structures do I have to make? I have to make count. Those many employees are there. So I'm going to make a new array of those many employees. Oh, we thought, cool. Okay. Yeah, you can also dereference PTR count like that. I think the only reason why this function is telling you to store PTR count like that is so that it can be, do you all remember pass by reference? Just for that. So that in other functions you can use count. Let's say if the other function that you're making is telling you to get the count, not the count. But out of all these employees whose salary is more than 50,000, it will tell you to create another function to check how many employees from that new array has salary of more than maybe 60,000. So you can use that count for reference, just for that. Apart from that, I don't see any use in this function, but yes, you can use that in that way too. Yes, and is the number of employees, like total employees in the old one. Count is the number of employees with this much salary. Okay, so I made a new array of this much count, and what I have to do is now do the deep copy. So for deep copy, I will be using my loop, and I will be doing int I equal to 0, I is less than n, I plus plus, and I forgot that before this, I had to make sure that I did int j equal to 0. You will see why. Uh, I I think array should be made later because I wouldn't know the count value. So in that, so I have a question in the chat. Uh, it's like if I made this new array before, I wouldn't know what count value should be or how big my new array should be. That's why I make it later, just to get this count. So if you all can see this till here, all this I did just to get the size of the new array. And someone said that we can use realloc. Yes, you can use realloc for this. But when you use realloc, what you're doing is you're changing the old array. So for that reason, I avoid using realloc. I don't recommend using realloc because the question never told you to change the old array. It told you to create a copy of it. So you should not use realloc, but yes, you can use realloc for not for this question. If the question in the future tells you to change things, you can, but not for this question. Because you're supposed to create a copy of it, not change the old information. Okay. So I made J. Right now, what I'm doing over here is I have this old array and I also have this new array. I'm traversing everything in my old array right now. And as soon as I see that my salary, if list I dot salary is greater than equal to this, then what I'm doing is I am going to go to list. Sorry, not list. I'm going to go inside my new array, which is this one, which is new J dot salary equal to whatever my new old salary was at that point, which is list I dot salary and new J dot name. Is name a pointer in this case? Okay, it's a pointer. So for this one again, I think so you have to create the malloc size of char into, let's say, we can put 50. And then I can do strcpy new, not new, list I dot name. Not that, I made an error. Wait, it should be new I dot name should be equal to whatever is at this particular location dot name. Yep. Because it's a pointer. If it was an array, I didn't have to do the allocation. But it's a pointer, so I have to do the allocation. Yep, I will come back to why we need J. Just give me a few more seconds. And then I do J plus plus. And in the end, when I'm done with my entire loop, this was just for the if statement, this is for the loop, I would return, why is this not working? Return, what should I return? Yeah, I should return new pointer that I made. Okay, so now, okay, I see that there are two questions. I will be going over why it's not new. Is it? All right. Before I go over this one, I would go over why I'm using J over here. So I is for the index for the old array, this one, and J is for the new one. Because let's say if my old array has 50 employees, my J, let's say, has 20 employees. What I'm doing over here is I am going to everything inside of my old array and checking if my condition is true or not. If it is true, what I'm doing is I'm taking the value and then I'm just adding it to that index. And as I've added that old value to my new index, I just increase j by 1 so that I go to the next point. And then I keep traversing, and if my condition is true again, I'm just copying that to my new j. And when I copy that new j, I'm increasing my value of j by 1. And then I keep doing this again and again till I find one more time where my condition of greater than equal to 50,000 is greater. And then I copy that information in this new index of j, and then do j plus plus so that it goes to the new index. So the next time if I have to add a new value, I just add it at this new index. Yes, I did do that here. It's just that I forgot to put it back, put it there while I was doing it. I just did it here. Okay. Now coming back to this question, I am going to repeat this again. This and this, same thing. Same thing. There is no difference between these two things. Oh, where j plus plus is happening. So it's like there's a question in the chat that j plus plus is happening. That is confusing. So it's just, you know how you have two loops? So instead of getting this two loops, I just used one loop. And it's a new concept for all of you. It's not something that you were supposed to know. It's a new concept. It's just I till n for the new one. Sorry, for the old one. For the new array, it's from j till count. You see what I mean? So it's just that whenever I'm adding, let's say if my salary was 20,000, 10,000, 50,000, I keep looping my old array. And then as soon as I hit the jackpot, I just put that 50 to my new one with the name of that person, let's say A. And as I have put that thing in it, I just have to do plus plus j so that I go to the next one. Yes, yes. There's someone who said, Peter said that thing that I'm trying to explain. So if you don't understand my explanation, you might be able to understand Peter's explanation. So yes, we are just creating this new array with only employees of 50,000 or more. So we are just making this new array of only those employees. Whew. Okay. Is there anyone who still has doubt on this? Why we use J? I know that it's confusing. If you're still unable to understand it, I would spend some time going over the code by myself, self-learning. Okay. If we still have time towards the end, I would go over this again. Someone had this question too. We're new. Can they use this? No, you cannot use this. You can use this. So this and this means the same thing. And yes, even this is kind of the same thing. But whenever you're using this, you don't use this access operator with this. Access operators. Both of these are access operators. And whenever you're using this, don't use this. So it's not right statement to use it like that. But you can do something like this, new dot main, if it's not an array. Okay. So if it's an array of something and you have to dereference it, use this. That is what I recommend doing it. Or what you can do is you can do something like this, plus I dereference dot name. Cool. How do you know it's an array? Either your question will tell you that it's an array. For example, you see this list pointer, it's an array. Or, yeah, the question will tell you that it's an array or not. So you don't have to worry about that. So this is the replacement for something like this. New plus I. Cool. Now this is the replacement for this. New Do you understand the difference? An arrow, we just use it in instead of this. Instead of these two things, we use arrow. But over here, we are using these two things instead of arrow. So instead of using an arrow, we are using these two things. And this dereference operator is similar to this dereference operator. Both of them are the same things. It's just that in this case, you're telling which index to free it at. Yes, you can use a J loop for that, but use a J loop only when only when the if condition is true. So instead of doing what I did, just use loop if it's greater than or equal to 50,000. So you can use J loop instead of doing J plus plus like that. Okay. New name. So this is a pointer. This is the member of the structure. I can write it like this, or I can write it like this. Do you agree with that? Do you all agree with this? Okay. Are you all listening or no? Okay. Now when I have an array, that means that there are many indexes 0 till n. So when that happens, oh, I have many names inside. Name 1, name 2, name 3, name 4. So which index should I dereference? For that case, instead of using this just one asterisk sign, I use this. I use its sibling, which is this operator. I say which index I want to dereference. I say I want to dereference the index I, or whatever the location is at I index, dot access the name and do this. These two things mean the same thing. Now, I don't recommend using this for arrays because all of you will make mistakes with that. Don't overcomplicate it. Stick with this. Stick with only this. or this. For just one array, use this or this. Not for one array. For only one structure pointer, use this or this. For array, use this. No need to use this with arrays. Don't use that. Cool. It's just telling you to go to this index, dereference, go inside the fridge, get this item from that. That is what it means. Okay. Coming to fifth question. The following structure represents a music library. The library array, each songs array, all strings are dynamically allocated. Type diff struct. So I have title, lyrics, number of lines, and all of this is stored inside of structure whose nickname is song t. Okay. So now I'm supposed to write a function to free all heap memory for an array of songs. So I have this free library. I have this library. It says that it's an array of songs. As I said, the question will tell you if it's an array or not. So this is an array of songs. And this is the size of the array. So I have an array. And it's from 0 till n. And now I have this function over here where I'm supposed to free everything that's inside of this that already is made. So I am just going to make a loop. Every single time whenever you have to travel or traverse the list, you make a loop. I is equal to 0. I should be less than n. I plus plus. And then I have all these things inside of it. Which thing do you want to free first? Title, nice. Okay, so for this one, again, I have title, I have lyrics, I have this num lines, out of which this is just one single pointer, and this is an array of pointers. So lyrics is a double pointer. In this case, did it tell you? No, it didn't tell you. So you always start with the smallest value. Wait. Yes, it's the amount of lyric lines. Yes. Cool. So over here, you always start with the smallest value. So in this case, if you see, we have this double pointer, which is supposed to point to, let's say, some other pointers. And we have title, which is supposed to point to, over here it says characters, so strings. And then this is just an integer, so it's not pointing to somewhere else. And on top of all of this, I just have one big structure called library. So you always start with the smallest thing, and in this case, title is the smallest thing inside because it's just a single pointer and it's not a double pointer. So I'm going to begin with that. And I begin with free. Now, I have to go inside of this pointer. So that's the only way I can access this structure. So I use that pointer. And as soon as I do that, I see that I have to dereference it for all of these indexes, I from 0, 1, 2, 3, 4. So I dereference it at this index, I. And as soon as I dereference it, it has title in it, it has lyrics in it, it has number of lines in it. So I just want to focus on title. So I use this dot operator and I say title and I just free it for every index, for every I that I go to. Then later on, what I do is I go to for, I make another loop, int j equal to 0. J is less than library at index I dot num lines j plus plus, and then I'm supposed to free library at index I dot lyrics j. So I know that this will be confusing for people, and let me explain how it works. So library, you're just freeing the title because it's a single pointer. You start with the smallest thing, and then you have j equal to 0. J is going from 0 till the library's index for the num lines. So what you're trying to do over here is you're going to that index. Let's say you're over here. You're going to this index which is 0, and you're trying to access its num lines, which is like the number of lines in the lyrics. So you're going from 0 till how many number of lines there are for lyrics. And what you do is when you go inside of it, you are freeing the library at that index. You're trying to dereference at that index, go inside, and then when you go inside, you're just going to free that lyrics inside of it at that index G, because we are going from 0 till lyrics line. So now again, it's like one thing inside of the other thing. So you're just trying to free everything from here till the end for that lyrics line. So all of this that you see, you're just freeing that till the end. And once you have freed both of these things, then you can come out and then you can free your library pointer, which was pointing to all of this. And that is it. Um, yes. If you tried freeing the lyrics first, uh, mm, I would say if you're trying to free the lyrics first, that can also work. It won't affect your title, but do it inside that one loop. You can do both of them at different times, it's fine. The reason why I did title first was that is the first thing that came to my mind, is that title is just a single pointer, so I can easily get rid of it before I start focusing on lyrics. So if you see over here, array of dynamically allocated strings, so lyrics has strings in it, like lots of strings, and you have to free each one of them. So you have num lines strings. Those many strings exist. So you have to free that. Technically, yes, you can. What you can do is after you're done doing this, you can write this. But it's just that it came to my mind before that. That's why I did. It doesn't matter for this case. For this question, if you did free title here, that would have been fine. So the only part I think is will be confusing for students is this part, I would say. This, I think everyone is fine with this, right? Awesome. Yes. It should be freed outside of the loop. Uh, yeah, I made that mistake. This shouldn't be here. This should be outside. Outside every loop that I have made, it should be outside of that. Cool. And where is it? Okay. If you want, I can go over this part again. So what I'm doing is for lyrics, as it's a pointer, a double pointer that is pointing to this strings. It's a dynamically allocated strings. So it's pointing to the address of all of these strings, which is char pointer. And I don't have access, like I don't have any value to free those char pointers. So I'm not going to free those because I think this question was supposed to be better formatted. But again, this is a question that I made, so it's not better formatted. In the exam, it will be better formatted. So I'm going to everything from 0 string to till number of lines string. So I made another pointer which is inside. And what I did is I made sure that I dereferenced my library before, and then I dereferenced my lyrics because it existed within that, inside of that. And you have to do it for every song. Each of this is a song, and every song will have all of its lyrics line. So you have to do it for every song. That's why it's inside of loop I. Yes. So I is for the songs, and J is for the lyrics. So for every song, it has a title which we already freed, and then it has lyrics. Lyrics has all these strings in it, which represents the lyric lines from 0 till number of lines. And we are just looping through every single one of them over here, going from 0 till number of lines. So I free my library. Oh, why is it doing that? So I'm freeing my library. Sorry, not freeing my library. I'm going inside my library, accessing only the lyrics, and then freeing that J part over here. If it was more appropriately framed, what I had to do was free all of the strings that were in it. Cool. Yes, you're right. We do have to free lyrics after this. My bad. That is what I missed. Free library at I dot lyrics. So when you have freed all of this, all everything like all of these strings, then you have to come out and free this address where it's pointing to the complete thing. And then when you come out, you have to free this entire thing for the library. Yes, thank you for pointing that out. Are there any questions? No questions? Okay, to know which one to free first, it's like one thing inside of the other thing. So let me just draw the diagram again. Let's say in my array, I have only two songs, song 1, song 2, and I have this pointer, library, which is pointing to this address. And my song 1 has title in it, which is a pointer. It has number of lines in it, which is it's lagging a lot. And then it has lyrics in it. Which is pointing to, wait, this lyrics is pointing to an array of strings. It's like how you read the lyrics, right? You have many lines of lyrics from 0 till number of lines. Okay. So you always begin with, you see this connection is going from this till this. So you always begin from the end point. You always begin with the smallest thing. So you began with this. I didn't begin with this because I was like, title is there. Title is not related to lyrics. Title is not related to lyrics, so I just freed it. But if it was inside of lyrics, I cannot do that. I need to free it inside of lyrics. So I have all these strings. Is there someone with the songs for the lyrics? Wait, with the lyrics for any song? I don't know. I'm just going to write gibberish. So all these lines are there. So we are doing j less than equal to number of lines is because we have all these strings. We have number of lines. We have those many strings. And we have 0 till n strings, which are dynamically allocated. So we have to go to each and every j loop for lyrics. And free it for each one of them. And once we freed it, we have to free the entire lyrics. Once you have freed the entire lyrics that doesn't exist, then you free title, so it doesn't exist, and then you free this entire song. And then later on, you do the same thing with songs where you just free its lyrics, the title, and the complete song. You keep doing that for every song, and then you free library. Does this help? Yes. Lyrics is just a double. Okay. Lyrics is a double pointer. You all agree with that, right? The reason why it's a double pointer, it's storing the address. There is lots of lag. Storing the address of char strings. Pointers. That's why um It won't matter because title and lyrics are not related to each other. So if you just free title before, it doesn't matter in this case. If title was inside of lyrics, you would free the title, then you would free the lyrics. Okay, I'm not going to spend more time on that. And I don't know why it's lagging a lot. So for this one, write a function that searches a singly linked list for all occurrences of the value n. And I know that if I go overtime, I can spend at least half an hour more going over the functions we couldn't go over. And I don't think so. The other questions should take that long because they are recursion. Recursion is more intuitive than understanding. So it just depends on how good you play chess. I don't know why, but if you're good at chess, you're good at recursion. I've seen that with people. Because for chess you do have to think in the same way that you think for recursion. Okay. Coming back to this, a function that searches a singly linked list for all occurrences of the value n. Every time you find n, I didn't give the structure for a linked list over here, but this is how it would look like. Type def struct. Okay. Yep. So let's say if the who was your professor? Okay. Okay, I see that. Okay. So this is the name of my structure. Wait, you know what? I made an error in this. This is not how it's supposed to be. I mix that up all the time. It's called node, and this is next pointer. So for this case, you have a function that searches a singly linked list for all occurrences of the value n. Every time you find n, you insert a new node. For example, let me give you an example. No, let me just write it in terms of numbers. 5, 4, 3, 5, 4, 6, 1, 3. Okay, so let's say my n is equal to 5. And let's say my m is equal to 100. So as soon as I see that my n 5 is there, I have to insert that number 100 after 5. Then I keep traversing the list. If I see it's 5, I insert 100 after 5, and I keep traversing till the end, till it reaches none. So that my new linked list will be like something like this. Is everyone fine with this? Sorry, 100. Cool, okay. So now, if this is how I'm supposed to do it, always make sure that there's something in your list. Always check for null, whether there's something in your list or not. So if this is the head of my list, so let me draw this out, head. This is next. Null. 5, 4, 3. My head is a pointer. Always keep in mind that my head is separate than the list, then the linked list. It's a pointer. It's not the node. Head doesn't have data in it. Head is just a pointer, which is pointing to this address of linked list. You just use head so that you have access to this entire memory. You know how you used ptr equal to malloc before? Head is like that. We just call it head because this is our head and this is the tail. Keep that in mind. This head is not the node. This is just telling you that this is where the first node is at. My first node is at X. That is what it tells you. If my head pointer is null, it's pointing to null, then head equal to null, then that means that there's nothing in it and I can just return. I don't have to do anything. It's void, so I can just type return. All right. Now, if it's not null, that is where my thing comes up. And if you see over here, I can use recursion or loop. I can use both of them. So I don't know, as your professor taught you recursion, your professor can try to mix up all these two things together, where it asks you to do recursion or loop. I don't know if your professor will do something like this, but let's hope not. So for this one, I will be using loop, and I will also share the answer in recursion format. If we have time, we can do recursion too. So whenever you have to recurse or go through a loop, you cannot use head to traverse the list. Don't use head. Always make another node. Let's call it walker to traverse the list, and it will also point to head. So this is what I did. I have a linked list. I made a pointer called walker, and it is also pointing to the same address X as head. Right now, I'm just looking at the first index. The reason why I cannot use head is that head is supposed to point at the first node. Head is the only reason how you know that your linked list exists. It's again the same thing as I shared before. PTR equal to malloc. Size of int. You create this space using malloc, and then you have this PTR pointing to this malloc. This is the malloc space that you made. And you're using PTR to access this memory. In the same way, linked list is also memory, dynamic memory. And to access dynamic memory, what do you need to access dynamic memory? Nice. And how would you access that dynamic memory using malloc? What else do you need to access that malloc memory that you made? Nice. Pointer. Because this memory just exists. We don't know how to use this memory. We don't have access to that memory that we made. So we have to use pointer. That is the only way we can access to the memory. Yes. So we also made another walker, which is also pointing to the first node of the linked list. So the reason why we cannot use head is that the only reason we use head is to tell that this is the first node of my linked list. And if in the future I make my head jump from first index to second index, let's say if this is head, if I tell it to go from here till here, I lost access to this. I don't have access to this anymore. I lost access to the first node of my linked list. That is wrong. So you cannot use head to travel the list. Yes, the more you travel using head, the more you lose access to this. And you know what happens? This memory is just existing in the system, and it will be memory leak, if you remember. It's the same concept that you used before. So don't use head to travel your linked list. Make another pointer. In this case, I used walker. And then I'm going to use that walker to travel my linked list. So I will be using while my walker is not equal to null, what I'm going to do is I'm going to check if Walker Walker is a pointer. So I have to use this arrow right now. Data is equal to whatever n is. Let's say if it's 5 in this case. If Walker, I'm dereferencing it and then I'm accessing only data. I'm not accessing its next pointer. I'm accessing data. Is equal to n. Then what I have to do is I have to make a new node. And to make a new node, it's again dynamic memory allocation. So I have to, oh, why is it doing that? New, it has started lagging. Node is equal to malloc size of node. So I created a new node with, what do you say? This is the pointer that's created this new node. This pointer has access to this node that I just made. So new node is pointing to this node that I made just now. What I'm going to do is I'm going to give this new node a value. And what value should I give to this new node's data? New node is a pointer. I use the arrow. Data is equal to nice m, because that is what the question said. M. And what should its next be equal to? What do you think? Okay, so I see that this is the place where all of you get confused. Okay. So I made this new node and I entered 100 in it, which is m. Let's say if m is 100. Right now its next pointer is pointing to some garbage value that we don't know. So this garbage value should be pointing to somewhere valid. Right now we have head, which is pointing to the first node. We have walker, which is also pointing to the first node. Now walker next. This is my next pointer, is equal to 4. And we are supposed to insert my new node over here, right? Do you all agree with that? Awesome. So my new node next is equal to my walker next. My walker next is pointing to this. Yeah, it's lagging bad. X plus 1. So I want my new node next should to also point to x plus 1. That is what I'm doing, because I want to insert over there. Now I have to make one more thing so that new node is pointing to this right now, but I don't have my first node pointing to this. So to make sure that my first node points to this, so that my first node's next pointer points to this, I have to write that statement too. So what I do is I write walker next. Sorry, not walker next. I just don't, oh wait. This is lagging. It's not letting me. Oh, please. Oh. No. Wait. Okay. It fixed that. Okay. So now to make sure that it does that, what I do is I say Walker is equal to new node. Wait, yes, it's supposed to be Walker. Oh, let me fix the diagram. Right now we wrote code where we said that new node's next is equal to Walker's next. So right now we made sure that we have something like this 4 and 100 is here. So now Walker next. Yeah, it's why aren't you writing? Wait. Next is equal to. So this Walker next is supposed to be equal to wherever my new node is. So my new node is pointing to this. So I'm just telling it to point it to there. So now, what yeah, someone replied to that. Thank you. So my Walker next is supposed to be equal to my new node next. Whenever it comes to linked list, always make sure that you try to do it from right to left, where you make sure that it's this axis is made first and then this axis is made later. So you do right to left. That is how you allocate its pointers, next pointers. Because let's imagine if we did Walker next equal to new node, what happens is it becomes hard to connect this to this. What I mean is that try to imagine swapping these two places, your code won't work. So this is pretty important that don't swap these two places. First connect the next pointer of your new node, then connect this entire new node to Walker next. Is this fine? Okay, and now that we connected this new node, what we will be doing is, this is my next right now. Okay, so my new, sorry, not new node, I don't have new node anymore. So I have, this is my Walker. This is, oh no. It's lagging bad, I'm sorry. This is still my Walker. And I'm supposed to go here now. Ah, it's fine. So now, so that I can go there, I just do Walker equal to new node next. Okay, as my new node is pointing to 100, so if I tell it to dereference, go to its next, and put that value for next. Let's say if next is y, give that value to Walker. So now my Walker is over here. So this is how you traverse it. First connect it and connect it from right to left, and then you make it point to that new node. So what I recommend doing is always drawing it out and then writing it in code. I think that's the best way for CS1, drawing it and then writing it. So yes, always connect it from right. Connect it, connects. Okay. First, make sure that make sure that new nodes next is equal to walkers next. This is always going to be your step. So make sure that it connects to the next part. And then the other thing that you have to do is this new node should connect to the previous walker next. Then after connecting it, just traverse till the end, till it reaches null. That was it. And if that's not the case for a statement, just do else. What do you think we should do? How to traverse this? Walker equal to walker next. That is how you traverse it. You just keep telling it to go to the next location, next address. Okay. We couldn't go over all these questions, and I know that we are out of time. Are we out of time? Yes, we are out of time. What I can do is I can go over 2 questions that you want me to go over, and then we can end it. Is that fine? Yes, the answer key will be posted. So I would say, to me, this question is very simple. It's just knowing how to write the function for it. Once you look at the answer key, it's pretty easy to understand how you do just r minus 1, c minus 1, just that, or r plus 1, c plus 1 to go up, down, and left, right for all those cases, or not changing the row and column at all. That's fine. I didn't go over base conversion, but I'll post the shortcut keys for that. So you can tell me 2 questions to go over. I can go over those 2 questions and we can end it. Which 2 questions do you want me to go over? Yes, we can draw the recursion tree. That question, cool. So for this recursion tree, how to say this? Okay. Whenever you see this recursion tree, did it tell you which function? Okay, 3. So you're passing 3 here. Is my n less than equal to 0? No. And I recommend using pencils on your quiz. Please don't use pen. I've been there. Don't use pen, use pencils. If you don't have pencil, it's fine. I can bring few more pencils for you and for your exam, for your quiz. If you have Tanveer Ahmed, because that's the only class I attend, I can bring pencils for you if you don't have it. But use pencils, don't use pen. Is my n less than equal to 0? No. So I don't go in my base case and I just print my 3, which is 3. And then I do res n plus this. So n plus func 2. Okay, before I do this, I was supposed to also write something like this, func 3, because that is how you began your recursive tree. Plus func 1. So we don't know the value for func 3. No value, no return statement. I don't know what's the value or what's the return going to be. So I have to keep trying to go and check what value for func3 would be till my computer can find the value or the return value of my func3. Do I know the value of my func2? Nope. So I have to go back to 2. So over here my n was 3. So I'll just write 3. Now I'm in my 2. Is 2 less than equal to 0? Nope. But I'm supposed to print 2. So I'll print 2. And my res is equal to n is equal to n, which is 2, plus func of 1 plus func of 0. Now, I am stuck with this function call, not this one right now. I still have to go over that one, but I'll come back to that later once I finish this. Okay, so I'm going to go inside of this one. So right now it's 1. Is my n less than equal to 0? Nope. So I print 1, and then I'm again back to this where it's res equal to 1 plus func 0 plus func minus 1. Now I have to call this function. So I go back to that function where it's 0. And then I see that my n has reached its base case. So I just return 1. So I just return 1 to this. I come back to this where I left off. I return 1 to this. So this is 1 now. And I start doing this. My compiler is like, oh, I have to continue my calculation. So now it's doing this. It says func minus 1. So now it's minus 1. It goes inside my base case. And then says return 1 to this. So it returns 1 to this as well. So now it's 1. So 1 plus 1 plus 1, my res is equal to 3. And then as I calculated this entire thing, I reached the semicolon. It says to return res. So I return res back over here. So my 1 is supposed to be 3. Now 2 plus 3 plus func 0. When we calculated this function, we got that this returns 1 for us. So we just use that. So 2 plus 3 plus 1 will give me 6. As soon as I reach my semicolon, it says to return res. So I return this value back to func2, which is 6. I know that func1's value is 3 that I calculated from before. I used that. So it's 3 plus 6 plus 3, which will be 12. And in the end, when I have to return my last res, func3 is equal to 12. Nice. All right. Which other question do you want me to solve? I have this one or this one. This one is printing the product of all. Printing the product of all odd numbers. And this one is counting the digits. For 10th one, I think it's easier. It's the easiest one out of all the questions. It's easy to understand. You don't have to think much for this. Once you just look at the answer key, you will be fine. So I have 8th or 7th. Or do you want to? Okay. I've received one person who wants to do 8. 6th for linked list. Oh, okay. I will go back after we do this recursion question. Is that fine? And I know that linked list is important for your exam. Cool. Yep. So I'll do 8. I would say 8 is a pretty difficult logic. Not the recursion part of this is not difficult. It's the logic that's difficult. So one thing in computer science that I want to tell you is that wherever or whenever you're asked this question, even in interviews, whenever it involves digits, always think of these operators, this one or this mod operator, division or mod operator. It's always in terms of that. So let's say if I have 5, 7, 8, divided by 10. What's the value? Yes, I will be posting the answers for this. I'll be posting the answer key for this. Don't worry. And I will also post like this base conversion, how to do the base conversion. For that, I will be posting the answer for that too. I know that I have no question on base conversion, but I'll do that. Okay, coming back to this, 578 divided by 10. What's the value for this? Nice. So it will print, sorry, not print. It will return 57. And if I did 57 mod 10, this will return 8. It's the remainder. It's like, boop, just the remainder. Okay, so for this question, it says count digits that counts the number of digits in a positive integer n. Write a recursive function count digits that takes an integer n greater than 0 and returns the number of digits in n. Now that you have read the question, what do you think the base case should be? If I keep doing 5, 7, 8, this gives me 57. 57 then gives me 5. And cool, I got one answer as if n equal to 0. Nice, good attempt. Let's say if I have 5, 10. This would give me 0. Cool. The 0 will give me again 0. And then it keeps giving you 0 if you keep doing that. So good. If n is equal to 0, you just return 0. You don't wait. You return 1. Let me tell you why we return 1. And one thing, how to do this? The recommended way to do this is that people don't wait. Oh, okay, I see. If I don't think so, we should use 0 over here. Or if we use 0, we have to use 0 over here. Okay, let's stick with 0 then. So when you read 0, you don't have to return the number of digits in it. And then if it's not that case, what you have to do is you have to just return 1 plus count digits and divided by 10. Oh. And divided by 10. I see that someone in the chat said this. Yes, we can also write it that way. If n is less than 10, that means that you're getting values like 5, or anything that is less than 10. You just return 1 digit for this because you still have one more thing left to do, or else you just return 1 plus count digits and divided by 10. So you can stop till you get 0, or you can stop one place before you get 0 and then consider that digit, plus you add all those digits here. You can do both the ways. I think the most professional one would be this one, but even this works. So whatever your brain thinks, use that. Yes, 6 or 5 is not equal to 1. But the reason why we return plus 1 is I did this. Okay, when I did, let's draw a recursive tree for this one. Always when you write your recursive code in exam, always draw the recursive tree and check if your recursive function is working properly or not. So for this one, CD 578 is my n less than 10? Nope. So what I have to do is I have to return 1 plus CD 57. Do I know the value of my CD 57? No. So I have to calculate that. Is my 57 less than 0? No. Less than 10? No. So I have to do 1 plus CD 5. Is my CD5 less than 10? Yes. So it returns 1. So you do plus 1 here, it becomes 2. And then you add 2 here, it becomes 3. You see why I had to add 1 to that? Because I was stopping one place before this, before the base case to do that. And I would recommend using less than or equal to 0 for this one. Do you all understand why I had to add 1 to that? Oh, okay. Yes. Yes. Yes, it is counted. So as I said, once you write your recursive code, draw the recursive tree. I think you need to be better at drawing recursive trees and writing the recursive code, because then you know where you went wrong. So yes, become better at drawing recursive tree. Is the best way to see if your recursive function is correct or not. Coming back to the logic of this, 5, next. Next is my pointer. And it's not. Let's say n is equal to 5. No, 6. And m is equal to 100. So for this case, if I'm traversing my walker from this address, I see that 5 is not equal to 6. So I traverse my walker to next, where I see that walker is equal to walker next. So that just means that my walker is going to go inside again. I can write this arrow in terms of this to better understand it. Walker next. So my walker, I'm dereferencing it. So it's going inside the box. Seeing that there are two things inside the box, which one should it access it? It should access next pointer. So my walker pointer So my next, its value is y. Here my next value is z. And here my next value is null. So what I'm telling is my walker right now is pointing to x. But it shouldn't point to x. It should point to its next. Whatever this next value is, it should be equal to that. So you just delete that and make it point to its next, which is y. This is how you traverse the walker. Is this fine? Cool. And now, when it goes to y, my walker is pointing here right now. My walker is here right now. And as it's there, it's checking if it's data, which is this one. So you just dereference it, or you just use the arrow operator, dereference, access data, and check if it's equal to n or not. If it is equal to n, yes, it is equal to n. So what I do is I create one more new node of type node, and I add m in it. I make its data equal to 100. And next, it should be equal to z. Oh. its next should be equal to z. How would I do that? The only way I can do that right now is through this next, because that is equal to z. So what I do is my walker next this thing is equal to z. So in that way, okay, when I created this new node, I had this pointer new node through which I was able to make this dynamic memory. So let's say if it's addresses A, it's addresses A. This is how I was able to make this new node using this new node pointer. So now its next should be equal to walker next. And as it's equal to walker next, what is happening here is that this next is pointing to z right now. And after that, I have to make sure that I make my walker next, which is z right now, equal to a, so that it points over here. So in that way, I just change the value of my walker next equal to new node, because my new node has that value, a. Cool? Is this fine? Is the logic fine? Yes, until you reach n. And what you do is you just manipulate next pointers so that you can insert this node between 6 and 8. Yes, for linked list, you always have to create a node, and to create the node is using this exact same format over here, which is you create malloc, you create a pointer with malloc for that node, you give its data some value, and you also make sure that its next is pointing to some value. Cool? Yes, node walker should always begin from the first index, from the first node. So you make sure that you're beginning from the first node, because why would you even traverse the linked list if you don't begin from the first node? Head is pointing to the first node. Yes, you need to spend more time, even though I did it. I went over this, I was lecturing. I want you all to spend more time going through the questions. And as I said, that for CS1, all of you are just listening and not practicing, not doing it actively. Come to SI sessions. There are sessions where I just sit there doing nothing. I want my sessions to be filled with students, even though it's not compulsory. It is necessary for you to understand CS1. So come to sessions, because I go over this. I don't give you answers right away, but I guide you towards the answers, if that makes sense. You learn in the lecture and you implement all that learning during SI sessions. So come to sessions. Okay. For the questions, for the other question, for all of the questions, I will be posting the answer key within 2 hours, I think. So just keep a lookout on the announcement, and till then, just practice for your quiz. Okay. Yep. You're welcome. Yep. Okay. All the best for your quiz. Bye bye. 2 hours. Give me 2 hours. Bye.